Good morning, everyone. I am Fiona from 8Ho. Today, I'm going to present an experiment about buoyancy. Which stationery sinks the fastest? Pens were excluded from this experiment because we figured out that pens won't sink. We assume that pens are empty in the middle and it's made mostly with plastic. So that's the main reason that it won't sink. Although rulers are also made from plastic, the ruler we tried sank. So we included it in our experiment. But we soon figured out that it was a mistake. First of all, let me introduce the experiment. Which stationery drops the fastest? The background. Although the speed of an object sinking doesn't matter everything, it matters to submarines. Correct timing has become the most important thing people care about. A submarine sinks by letting water into the tank. It's kind of related to this experiment because the water moves into the stationaries to make it heavier. And the purpose of this experiment is to see how density affects the sinking speed, although we didn't really measure the density of each object. Next, the hypothesis. I inferred that the stapler will sink the fastest because it's the heaviest, since it contains metal and the volume it takes is fairly small compared to the mass. So in other words, the stapler is very dense. Other than stapler, I think the ruler will take the most time to sink because it's made mostly of plastic, as I mentioned in the introduction. And here's our procedure. We made the procedure into a GIF instead of a video because it only took us about 2 seconds to do the experiment. So the GIF on the right is our procedure. As you can see, it's very easy. Just put the object right on the water surface, probably a little lower. Then start the timer as you drop the object. When the object touches the bottom, stop the timer. The steps you should be careful the most is to start and end the timer with the object. That's also the hardest part. Now I'm going to share a result. The subject for this chart is seconds. In the result chart, the most eye-catching numbers are the ruler and the stapler. The ruler took 13 seconds on average to sink, and the stapler took 0.3 seconds to sink. But that doesn't surprise me. The coins result was the one that surprised me, because I thought the $50 coins should sink the fastest, since it's the heaviest. But after thinking the question again, I realized that although the $50 coins is the heaviest, the volume it takes is also the biggest compared to other coins. So from the result above, I learned that weight does not affect how quickly the object sinks. Instead, density controls it. After seeing the result table, here's the graph of the data. We didn't include the ruler because there would be a huge gap between them, and the graph will be useless because the only thing you see is the ruler's block is tall and the other stationaries are short. But that's not my point of making the graph. I made the graph so we can see the tiny itty-bitty difference between the result. And as I mentioned 100 times before, the stapler drops the fastest. And it's easy to see the result with this table. And as you might notice, some of the result was different from each child. For example, the $10 coins took 0.2 seconds to sink in the first trial, but it took 0.4 seconds to sink for the last one. This happened because I'm not a fast reactive person, so I might press the finish button too fast or too slow. According to the data collected, our hypothesis is correct. After doing further research, we found out that metal is denser than water's density, while plastic is lighter. So when we put the ruler in, the top part stays on the water for a while before sinking. That's because it's made with plastic. And as I mentioned before, the only mistake we made was to put the ruler into this experiment. We should not put the ruler into this experiment because it ruins our graph, the average, and most importantly, it makes this experiment unfair. We gave the ruler a gentle push because it was taking too long for the ruler to sink. So the ruler's time was kind of flexible. Last but not least is the evaluation. The two problems we faced was, first, our tub was too small. As a result, We don't have enough time to react. It's like pressing for the start and pressing for the finish again. There's not even a second for me to react. This problem also leads to us to the second one. We are not accurate enough. As a human being, it's impossible for us to be more accurate than machines. So I thought about adding a sensitive timer at the bottom of the tub. So when the object touches the bottom, the timer will stop itself. But that's impossible to be real. And thank you everyone. This is the end of my presentation.